Good afternoon, everyone. Great to see a good range of producers out there and many colleagues as well. And many thanks for having me along today. So I'm based in Mareeba. I work within the North Queensland Sown Pastures and Beef Extension team, and I'd like to recognise their expertise and support as we work with a range of producers to try to get legume pastures going on their properties. Special thanks to also a range of producers that we work with every day, developing demonstrations and research trials so we can test and promote the use of legumes. Finally, I'd like to recognise the support from Livestock Australia and the Australian Government for supporting the program, which again, as we say, the focus is on legumes, trying to get some legume adoption happening in Queensland. Okay, as Katie said, this is part 2 of a range of talks that we're doing on Legume Establishment. And this time our focus is on the monsoonal tropics. It builds on Gavin's excellent talk of a few weeks ago, where he talked about legume adoption in the Brigalow belt, and he also covered the key principles of pasture establishment. So I'd encourage you to go back and have a look at that talk. The key message from this map here is that there are a range of climatic zones within Australia, and each of those provide different opportunities and constraints on plant growth. So although you can see there are a range of zones up in the monsoonal tropics, we can broadly break them down into 2, into the wet tropical coast and to the dry inland zone. So that's what we'll be talking about today. Okay, so while the excitement about with industry and the government and encouraging people to develop legume pastures using legumes which have come from overseas, I hope to provide an argument for their use and provide some tips on how to get these into their pastures. We've known that these are useful tools for a long time now, and we know the methods to get them in there, but farm establishment remains an ongoing problem. So I'd like to talk about some of the experience we've had with our producers in recent times. Hopefully you'll get something useful out of it, and these methods can broadly be used across the north as well, not just up in North Queensland. Okay, unlike the Gavin's talk, where he was dealing mainly with sown grass pastures and mainly buffel grass pastures down there, much of the beef production in the northern zone is based on native grasslands. Sown pastures are used though. We use them on the coastal strip, where we have removed all of the original vegetation. And we also have sown grass pastures on smaller areas on properties, usually on more fertile areas around homesteads, and these are often used as weaner paddocks or steer paddocks. There are a range of production systems. The dry inland zone is used to grow weaners or steers for store or live export markets, whereas on the tropical coast, there's capacity for high live weight gains, and animals can be backgrounded for slaughter as well. So we have a range of markets across the region. There's also a huge range in the scale of the properties. So along the tropical coast, many properties on tablelands are only a few hundred hectares, whereas you go inland, we're dealing with properties in the order of 30,000 hectares with relatively low stocking rates. So the productive capacity on a per hectare basis ultimately determines the approach of our legume establishment and the long-term management of those legume pastures. So low input systems in terms of their preparation, their seeding rates and fertiliser application tend to get used when land types have low inherent productivity. For example, you might have a breeder paddock on a fertile ridge country, whereas more inputs are used when there's a greater opportunity to get a return on investment, and that's where you might be having, say, a weaner or steer paddock on the wet tropical coast. So it's all horses for courses. Okay, rainfall drives pasture growth, no surprises here. Up in the monsoonal dry zone, unlike further south, there is typically little or no rainfall component. The native grasses that we have in our pastures are well adapted to this, of course. They grow quickly in the wet season, and we usually get about 80% of our herbage yield over 3 to 4 months. They then seed, and they essentially become dormant over the dry season. On the tropical coast, the rainfall is more consistent and there's more of it, thanks to the trade winds which blow in for months and months on end. But this can still be a short dry period around September and November. But overall, you've got a much more regular a non-stop production system on the wet tropical coast. Okay, so what does all this mean in the dry country? So here are some feed quality figures that were collected from Springmount back in the 1990s. This is near Mariba on fairly infertile soils. The blue line you can see there is diet digestibility, and the orange line is metabolizable energy, which of course track each other very closely. So as you can see, the feed quality declines during the winter dry season, and it doesn't really increase until we get November rains, and then we get a rush of new grass. There's a similar trend in protein, which affects the capacity for cattle to digest stemmy grasses over the dry season. So these are our key limitations to productivity. They limit animal growth rates and reproductive performance over the dry season, and that feed gap is our major challenge. Our producers do manage this well. They do it through adjusting stocking rates, having inherently low stocking rates, and supplying supplements, but that can be a considerable cost to the producer. Now, if that wasn't bad enough, producers need to manage for considerable variation in rainfall between years and also runs of dry years. Whereas producers can plan for maybe 1 or 2 lean seasons, runs of dry seasons like this are a major problem. Ironically, very wet years can be a problem for those seeking to establish new pastures. They can miss out on their opportunity because the rain comes earlier than they expected. And last year was a good example. Many producers in the north were ready to go. They had seed ready to go, but we had an early start to the wet season from Cyclone Jasper, despite forecast dry year, and it didn't stop raining afterwards, and that meant that farmers couldn't sow their legumes in their pastures, and they're carrying up seed over for this year. Now, the productivity of beef businesses in the dry zone is completely reliant on the health of their native pastures. Queensland Government beef extension staff have been looking at a range of sites that you can see on the map on the right-hand side there. Since 2004, these have now been revisited three times, and just last year as well, so now 4 times. What we like to see in our native pasture is what you see on the top left. We have country in A condition. There's lots of 3P grasses, high ground cover, and few weeds. These systems are productive. They give good options for cattle to select good diet, and they recover well from stresses like droughts. On the bottom left is what we don't like to see. It's a system which is poorly functioning, very low productivity, and there is long-term damage to that system. And that's what we desperately want to avoid from our long-term production angle, and also from the environmental aspect as well, because there's considerable potential for sediment to flow down rivers into the Great Barrier Reef and into the Gulf of Carpentaria. I regret to report there's been a steady decline in land condition in the Northern Gulf region, retained from the start of that study. So that goes back to 2004. Over that time, there's been a loss of 3P grasses in many of those sites, an increase in timber thickening, and an increase in weeds. And this means that the safe carrying capacities that were historically considered to be safe have declined, or that the risk to damaging the landscapes by maintaining those original carrying capacities has increased. Now, we can manage this through grazing strategies which encourage management of those pastures, doing feed budgets, seeing what's in there and making sure that we rest pastures so that they can recover. But even they are limited in their capacity to address condition and land decondition like you see there. Another factor of northern Queensland, northern Australia, like most of Australia, North Queensland is geologically old and infertile. So on many landscapes, low levels of plant available phosphorus limits both our pasture growth and the productivity of our animals. And these animals often need supplementation. Phosphorus can be applied to pastures as fertilizer, but this is at a considerable cost. Luckily, most soils retain soil P pretty well, so there's no need for annual applications. On the right-hand side, you can see some graphs And that's from some work that was done in the 1980s, looking at the response of stylos to soil peas. So whereas stylos can grow well on low pea soils, they also respond very well to applied pea fertilizer. So there's an opportunity to increase productivity in certain situations through applying pea fertilizer. And many of our important soils in the north, like the red basalts and the alluvial soils, they're quite inherently high in soil P, so we don't need to tend to apply phosphorus to those, although they tend to be quite low in sulfur. So sulfur fertilizing can be useful. But generally, we're dealing with an infertile landscape, which ultimately limits productivity. And finally, in these challenges, we're entering some uncharted territory here in terms of temperature. Extreme temperatures can have a major stress on plants. The message is that they're going up, and we really don't know where this is going in terms of long-term damage to grass pastures. So I guess we need to watch this space, but it is something that we might need to think about in terms of the resilience of our pastures in the north. Okay, so our ultimate challenge is the extremely variable rainfall environment that we face in the north. Unlike some other forms of agriculture, beef producers cannot control the key driver of plant growth, which is moisture. Effective grazing land management is the key tool at our disposal, and that should always be our first go-to. However, other strategies can be used to overcome feed deficits, and the use of deep-rooted, drought-tolerant legumes is one method that we can use to iron out some of the extremes that we see in feed supply, and we can improve our diet quality at the same time. So this approach has now been used for more than 50 years, and much of that development happened originally in Queensland, although it was also readily adopted and tested in the Northern Territory and Northern New South Wales. So as Gavin said in his talk a few weeks ago, legumes can be used to improve nitrogen cycling in pastures through accessing atmospheric nitrogen. Of course, they can also be used through that system, process of producing high quality leaf, high protein leaf, which is available to cattle to eat as well. So we now have a range of legumes for use in the monsoonal dry tropics, and some of the key commercially available ones are shown up here. They include shrubby plants like stylos and desmanthus, along with twining plants like the atros, burgundy bean, and butterfly pea. There are options for different land types and different scales of production, whether you're trying to build up a breeder paddock with stylos or develop a smaller area to feed weaners or steers. Some, like the Katinga stylo you can see in the middle, are better adapted to a range of environments, and you can grow them on clay soils, medium and light textured soils, where others, like the desmanthus, are better adapted to clays, and the shrubby and Caribbean stylos have a better role in light textured soils. They also differ in their ability to survive repeated grazing, and in general, the shrubby legumes like the stylos and the desmanthus tend to tolerate more regular grazing better than the twining types. Okay, so we're introducing legumes. Where do they come from? So this is a map of where the pastures legumes were collected before they entered international foragers' collections. These collections are used to conserve what's out there in the world and also to develop new plants for agriculture. As you can see, the different legumes we use today were mostly collected in Central and Southern America. Luckily, we've got access to these along with other national forage collections through the Australian Pasture Gene Bank, which is now located in Adelaide, and that's been the key collection used to develop cultivars for for legumes over some 50 years, and it continues to provide that key resource for developing new pasture plants. So as Gavin alluded to in his talk a few weeks ago, a key benefit of using legumes is the quality of the diet that they can bring, particularly in the dry season when the quality of grass pastures are declining as the grasses seed and they hay off. So here are some protein and energy contents of a range of legumes that we sampled at our testing sites over some 10 years, and they've been averaged here. And you can see these are all dry season numbers. And the key message here is that the quality of the leaf is very high. So we're talking in the order of 15 to 20% crude protein, high levels of metabolizable energy, whereas the stem is not. So what we're really focused on in these legume systems is the amount of leaf that's being produced and what that can do for our cattle. The second key point of this table here is that the quality of the leaf and stem declines as it gets older. So as we're moving from 15 weeks to 26 weeks, is that there is a drop in the quality of those components, but it's really not too much. And the leaf still retains very good quality well into the dry season. So basically, message is legumes produce very high quality leaf. So what happens when we put these legumes into our pastures? Now, the stylos are the most widely adopted group of legumes in Northern Australia. There's 50 years of history to this. And the graph here comes from that same grazing trial I showed at Springmount a little bit earlier. The dotted line represents native pastures, and the solid line, native pastures with stylos that are grown with or without fertiliser. Up the top, you can see the addition of stylos has increased dietary energy of the pasture over the season, particularly when fertiliser was applied to support that stylo growth. And down the bottom in blue, you can also see that stylos have increased the amount of feed intake in the animal. So you're getting a dual benefit here. You're getting some high quality feed going into the animal, but you're also getting more intake into the animal as well. Here we have another demonstration that was done in North Queensland, again, back in the 1990s. And stylos here were introduced to native grass paddocks on some very infertile soils. And the simple effect of adding stylos was to greatly increase the amount of feed over the year. So the native pastures in green, stylos are in blue, and you can see the yield advantage that we've achieved in both dry years and wet years through the addition of stylos. Okay, so this idea of a production paddock where you can get a small area and you can establish some stylos and maybe fertilise them was tested again in North Queensland to feed weaners over the dry season. The stylos were only fertilised here at establishment, and the weaners were also fed some dry season supplements. And in this trial, the weaners grew about 50% faster in the stylo paddocks, and their stocking rates were tripled compared to native pasture. So we often see that. There's a bit of an animal growth rate advantage, but there's often a greater advantage in the number of animals that can be carried per hectare. And there's been a series of economic analyses done on this work now, and the intervention of introducing legumes and fertilising them were found to be the most profitable long-term option for beef producers in the seasonally dry tropics. Okay, so there's also a range of legumes for more intensive production systems. Now, Legume, as you can see, there is our Rolls Royce for the production on our more fertile soils in the dry zone. This tree legume produces high quality leaf further into the dry season than other legumes, and it results in unparalleled production for our weaners and steers. So after a decade of research, we now have an insect-resistant variety called Redlands, and this now enables Legume to be grown in some of the more humid areas where previously Legume adoption was limited by a little sucking insect called a psyllid. So good options there. There's also a range of useful legumes for the wet tropical coast and the tablelands, and these include centros, glycines, and common stylo that you can see on the right. Importantly, these all grow well with vigorous sown grasses because they're on this wet tropical coast and tableland environment where we're using sown grasses. And best management for these is to put them into spell grazing or rotational grazing type systems where you can maintain a good grass legume balance, but we'll talk a bit about that later. Okay, so what's the fuss about with Legume? Here we have some production figures that we achieved at Pinarindi from a trial that ran for 4 years with 4 cohorts of cattle. It was on an infertile red earth soil. And there we compare the productivity of a stylo buffalo pasture, which had been fertilised, with the productivity of Legume paddocks. Both were highly productive, and the steers averaged 0.6 kilos per head per day over 365 days, and that was repeated for 3 cohorts of cattle. In the wet season, productivity was particularly high, and the animals were getting up to 1.6 kilos per head per day, which represent excellent productivity in the dry tropics, particularly on those infertile soils. Now, the key difference between those two lines there, you can see the Legume is the yellow one up the top there, and the pastures in the blue is due to stocking rates. So essentially, the same amounts of weight gain were achieved with the two production systems, and they were still very good, but the Legume system was able to handle more animals per hectare, and therefore it produced more kilos per hectare. Okay, so finally, we've been using legumes in the sown pastures on the wet tropical coast for over 50 years. And to illustrate that, there's a nice photo of one of the previous pasture researchers who used to work out of South Johnston. And in many ways, the consideration on the wet tropical coast is that the adoption of legumes can be used as a way of getting nitrogen into systems and getting the kinds of responses that you might achieve by using bag nitrogen or fertilizer nitrogen. So in this trial, the productivity of grass legume pastures was compared with fertilized and unfertilized grass pasture. And the legumes achieved significantly higher stocking rates and therefore productivity per hectare than the unfertilized grass. But you can still see that the weight gains per animal on the unfertilized grass were pretty good there at 0.52. The big differences came through from the stocking rates. And one of the key considerations we have in this area as well is the frequency of applying fertilizer and what that can mean in terms of runoff. So legume pastures can supply nitrogen steadily if you maintain them well over 20 odd years. We've got paddocks on the tablelands which are now 30-year-old signal grass glycine paddocks, whereas nitrogen application has to be done regularly and it is a regular cost. And the application of soluble nitrogen also, of course, poses a risk to the wet tropics bioregion, because all of those rivers run off and into the Great Barrier Reef lagoon. So there's a lot of effort to try to avoid nitrogen running into the reef. Okay, so hopefully you're convinced that legumes are a good thing for the monsoonal zone. The next part is what sort of methods do we use to get them into pastures, and what are some of the key obstacles that we face when we're trying to get these pastures going. Okay, this is one of Gavin's slides and it's pretty good, so I've kept it in. It just runs through the key steps to produce productive legume pastures. Okay, so first of all, make sure you select the most appropriate paddock for the purpose that you require. Use the right legume variety for your land type. Aim to use a reliable established method and be prepared to think this through well ahead of time. It will make all the difference. Prepare a good seed bed. That's critical. We'll talk about that. Use a suitable sowing method for your particular situation. Encourage some good early growth, and that may require a bit of fertilizer. It certainly requires suppressing competitive grasses. And then there's a thickening up phase while the pasture gets on its feet before you can start managing it as a full-on pasture. So a good slide. We also recruited Charles Darwin for this work, and I think the first thing that we need to recognise the challenge that it takes to establish one seed, let alone millions of them. And Charles Darwin, I think he had it right when he said, with plants there is a vast destruction of seeds, but I believe it is the seedlings which suffer most from germinating in ground that's already stocked with other plants. And basically what he's saying there is that it's a hell of a job for a seedling to get going when it's competing for resources with plants that are already there. And in most cases in our pastures and with our legumes, that's the grasses that we're working with. So there's a constant battle of survival in there. And the other key message is that we do create an artificial situation when we make a grass legume pasture. So we need special management to get those seeds into the pastures. We also need special management, usually based around grazing, in order to maintain a good pasture and in good balance. Okay, so seeds are life's little achiever. And here's some of the things that they are. They are a DNA recipe for a gene line. So they are a way of keeping a line of genes going. They are a remarkable time capsule so that individual plants or those gene lines can survive runs of bad years, and legume seeds can survive 10 years in the soil and then be ready to go again. They are a very high energy source to produce a little plantlet to get the plant up and running before it can start using its own solar panels. And they are the complete package for establishment. But what they are not is a magic bean. They are not a miraculous thing that produces a new plant every time with no management. And I think sometimes there's an inclination to underestimate the challenge that individual plants have to establish within pastures. So that's what we're talking about today. Okay, so again, to germinate, seeds must be alive and not dormant. Well, that makes sense. They should have access to a prolonged supply of moisture and oxygen, and they need that for germination. And critically, there's got to be good contact between the soil and the seed in order to encourage the growth of that plant. Once it's put that little root out, it can't go backwards. It's committed. And for seedlings to survive, there has to be minimum competition with other plants. That was what Charles Darwin was talking about. It can't be eaten, flooded, zapped, accidentally sprayed, trampled, and there must be a supply of nutrients and moisture to maintain that seedling over time. So these are the 5 things that we recommend people do and pay attention to in the north to get their pastures going. Number 1, understand what your seed is like. Get a seed test. If not, do your own. Plant at the right time of the year. Minimize competition, particularly from grasses. Plant at the correct depth. If you plant a seedling too deep, it just simply won't have the reserves to come up to the surface, and that applies particularly to small legumes. And finally, make sure that you graze them carefully so that the pasture can establish well. Okay, this may seem like an obvious thing. Is my seed alive? But there are 2 things that seeds want to do. They either germinate, pass on some genes, or they want to die. And just remember that live seed looks just like dead seed. So the only really way to know what your seed is like is to do a test. Now, when you purchase seed, an official seed test must be provided upon request, and that includes 2 components. Now, it's really important to become familiar with these. There's a purity test, which tells you what the components are inside your bag of seeds. So that would be the crop seed that you're looking for, the amount of weeds and other material. And there's also a germination test in there too, which tells you how many of your seeds that you want to plant are ready to go in terms of germination, how many are dormant and they might come up later, and how many in debt. But what we recommend to all producers is to do your own seed test. Sometimes the most recent seed test that you receive from your agent might be a year old, might be 6 months old. So a lot could have happened to your seed in that time. So simply do a little germination test like the one you see there. That's simply a takeaway box, some blotting paper, and 100 seeds put on there, and a little spray bottle used to spray water on top of that test. And based on those results there, you can use those to adjust your sowing rates. Okay, now what about coated seeds? Now today, seed will often be supplied with an artificial seed coat, which, as you can see, comes in a range of exciting colours. These can be useful. They can improve the ballistic properties of seeds. And here we've got some Rhodes grass, and you can see that the capacity to spread that seed on the right would be quite difficult. Coating the seed makes that a lot easier. Thing to remember though is that there's been a big dilution in the number of seeds per kilo. So as a general rule of thumb, we recommend that coated seed be applied or sown at 3 times the sowing rate of uncoated seeds. Okay, seed dies quickly, don't let it die on your watch. So if you really want seed to die, store it in a hot shed in a humid environment, and we have a lot of that in North Queensland. Seed begins to die the moment it is harvested, and the rate of death increases with soil moisture content and temperature. So simply, the more hot and humid, the faster it dies. Good quality legumes should easily store for over 12 months, but grasses can absorb more moisture and they will die more rapidly. So if you're going to store seed for a long time, we recommend using a store similar to the one we've got here. This is a little store we use, it's air conditioned, and we can keep seed in here for 2, 3, 4 years in between plantings. And there's some examples of the conditions in that store. So there's 53% humidity and about 15 degrees in there. And that's enough to keep seed going for a long time. So whatever environment you find yourself comfortable in, it's generally a good environment to store seed. Okay, so when do we plant? We need some rain for establishment and we need some follow-up rain for it to grow, but we don't need too much. In general, up in the north, we don't need to store soil moisture as they do in central Queensland. This is because we get a very reliable pulse of rain with the southern movement of the monsoon trough. And you can see on the two tables there, we've got the dry tropics on the left and the wet tropics on the right. The best time to plant in the dry tropics is usually after first storms and before the monsoon trough comes down. So that's usually sometime around December. January is a good time to get your seeds in there, and that allows you to put some germination and enough rain to get the plants established before the dry season comes. On the right-hand side, the monsoonal tropics, we have a couple of options. We desperately want to avoid that heavy rainfall in the middle, and so we can test either sow just before the wet season with storm rainfall, or we can plant after the monsoon's gone away again, and when the trade winds are bringing in drizzle onto the coast. Okay, so there are a few rules of thumb that we use all the time for getting good establishment. First of all, sowing rate. Now, our recommended sowing rates usually relate to seed lots of medium to high viability, and they do allow for some losses. However, if your seed test is particularly low, you'll be wanting to compensate for those low results. You also need to compensate for the amount of coated seeds you've got in your seed lot. Sowing depth, the general rule of thumb is seed should be placed at about a depth of 3 times the length of the seed and then covered with soil. It's not always possible to cover it with soil, but that means that small seeds like stylos and desmanthus can really only be planted in the top 5 or so millimeters of the soil. Otherwise, they probably won't come up. And the most critical thing too is getting, again, that soil contact moisture. Small soil particle size results in better contact between the soil and the seed, and then there's better supply of moisture to the seedling. Fluffy seedbeds may look pretty, but they dry out very, very quickly, and seedlings can quickly die after they've established if there's no follow-up rain. Organic matter is really useful for holding moisture in soils, and where you can, manage for maintaining organic matter in these soils. And critically, roll after sowing. So you can see on the right-hand side, there's been some crops that have been rolled, there's been sown and rolled, and you can see the rills provided by the flange roller. Okay, oops. Right, now, the oldest method to establish legumes in the dry tropics is simply to broadcast seeds after a fire and before the grasses come away with rain. So sometimes we might broadcast seed with a ground rig or a chopper, but increasingly we're using drones, and we'll be doing some of that work next week up here in the north. The broadcasting after fire method has been used to establish stylos successfully now for 50 years. It's cheap, but the rate of establishment is very slow. You get a small proportion of plants surviving and germinating, and we're really relying on seeding events and spread of those plants over time in order to develop a new pasture. A relatively new method that's been tested in central Queensland is to suppress the growth of grasses with a light rate of glyphosate, and then then broadcast your seed on top or fly it on. You can see on the right-hand side, those pastures in central Queensland with some excellent establishment there. However, in the north, with some of our pasture lands, it hasn't been as successful so far. So if considering this method, I'd be treating it with a large degree of caution. At the other end of the scale is full cultivation. This is usually done on more fertile soils, where there's a better chance of a return on investment. This method enables us to establish new grasses and legumes and to incorporate our fertilizer during cultivation. Okay, it usually involves heavy grazing, cultivating, encouraging germination of weed seeds, controlling them with cultivation and spraying, broadcasting seed and rolling. It's a full-on expensive process, but you're very quickly into production, and you can end up with some very highly productive long-term paddocks. Also in the wet tropics, legumes can be drilled straight into healthy grass pastures, as you can see on the right-hand side there. Is a seed drill. Usually there's heavy grazing to suppress those grasses, but management of grass after sowing is really critical here, as the grasses can quickly grow and end up competing with your legume seedlings and completely overwhelming them. And when we're cultivating, the secret to success is that old thing there. That's simply a flange roller. It's a very heavy flange roller, and the soil seed contact that you achieve with that will result in excellent results for your seed germination. Now, the establishment of Legume requires specialist equipment and attention to detail. It's really a farming exercise. Multiple cultivations and herbicide applications are used, and we need a really weed-free seed bed. It's got to be friable, and we use a precision planter to apply the right sowing rate to get the right population of plants, and also plant Legume seeds at the right depth. Generally, there's a need to control grasses after planting as well. You might use selective herbicides for that, or more cultivation. And it may also be necessary to control grasshoppers, and it's very critical to remove any kind of grazing animal, as they can be devastating within these pastures. But there's a lot of work involved in making the systems. But at the end of the day, you'll end up with the most productive system we've got. Again, long-term pasture, we're talking 20 or 30-year pastures, which can be productive for your operation. Now, a good compromise method that we've been using in recent times is to get legumes going in strips. What we do here is we go into a grass pasture, we cultivate, spray, control any weeds, broadcast seed onto the surface, and you can see some fairly simple here, there. That little spinner only cost $120, although there are more precision ones, and then roll it afterwards, and that's all you need to do. So on the left-hand side, we've got a paddock that we established on an alluvial soil into buffel, fertile soil, and within 6 months there was 2.5 tons of stylo within those strips, and it was ready to graze. On the right hand side, it's a method of getting legumes with cultivation into woodlands. So that's on a red basalt soil, an Indian couch dominated country, and down the bottom there you can see the result after only a few months. So we've got a good population of grasses and stylos in there. The stylos have seeded, and they can now be spread throughout the paddocks. So the advantage of this method is that you can get a high level of establishment. You can do that quickly, and then you've got a source from where legumes can spread throughout your pasture. You can also decrease your sowing rates per hectare a bit because you're concentrating a lot of seed in a small area. And you can also concentrate your fertilizer as well into those legume strips, so you're only really feeding the legumes. Okay, and finally, some producers like to let their cattle do the work for them. There's a lot of hope in this system, but it does work. We know that stylos and desmanthus can readily pass through the ruminant gut. And on the right-hand side, you can see some seedlings coming up and some dung. Different approaches to doing this. You could establish small areas with access to larger paddocks. So this might be down a laneway, for example, or in the corner of a paddock. You might fence it off, work it up, and plant a good establishment of legumes. Encourage seeding and then bring animals in to distribute that seed. Alternatively, you might think about putting some out and lick towards the end of the dry season or in the storm season, and that's another option as well. But you're really dealing with very slow rates of establishment and dispersal. It takes a long time to spread throughout your country, and you're really trying to benefit the next generation when you're taking this kind of approach. Okay, so what about fertilizer? It's a really important question. I won't dwell on it too much in this talk because it's a whole talk in itself. But it is really important to recognise that in productive systems, for example, on the coast where there's heavy rainfall and leaching, it's really important to maintain good levels of nutrients for your grasses and also for your legumes. And that table there, again, I won't dwell on it. It's just a summary of what the kinds of levels of elements that that pastures need for high levels of production in those wet tropical environments. The key ones for a legume type system: phosphorus, potassium, and sulfur. Particularly phosphorus and sulfur, as it's involved in the nitrogen fixation and growth process of legumes. Legumes provide nitrogen throughout the system, so there's no need to apply nitrogen to those fertilizers, those pastures, sorry, but they also require molybdenum in order to fix nitrogen well. So how do we get those into the pasture? Well, we can apply the P, the potassium and the sulfur either at establishment, or we can top those up over years, over time. And this does require monitoring what's going on in your soil and doing some soil tests. The molybdenum is a trace element, and that can be sprayed onto your pastures. And usually we do it on tablelands after the wet season has gone through and there's plenty of legume out and about. So you encourage a good stand of legumes, you spray the molybdenum on there, and you should get a good response from spraying that moly to your pastures. Okay, there's also a terrifying range of fertilizers available. So the key message here is, if you're going into a soil testing and fertilizer regime, become friends with an agronomist. Come and see us at the DPI. We will help you with interpreting your soil tests and recommendations for your pastures as well. It's bewildering, but there is help out there. And finally, just a quick word about nitrogen and the bugs for nitrogen. Legumes, of course, can fix atmospheric nitrogen, but for different legumes, it does tend to work better with different strains of soil bacteria, and they may not be in your soils for your particular legume. And so what we're looking for is some nodules there on the right-hand side. We're looking for nodules that look like that, good functioning red nodules. And many plants can be quite fussy when it comes to the strains that they're using. So one option is that you can apply an inoculum to your seed just before planting. And you can see here we've got a specific one for burgundy bean, we've got one for desmanthus, and they can come in peat types like you've got at the top, but more commonly these days they're in the freeze-dried types that are at the bottom. It doesn't take much. In the bottom you can see that that little vial will do 100 kilos of seed. So overall, the use of legume inoculum is considered to be good, cheap insurance to make sure that you've got some bugs in your soil. Okay, sorry, but you can't always go fishing. In the monsoonal tropics, there's a very short planting window, and you've often only got a few weeks to move with, to work in, and that move may move quickly and without much notice. So you've got to be on hand. And the trick to this is being organised early. So it involves planning 6 months out, especially if you're doing major changes to your paddocks. And at a very minimum, 2 months, you should be getting very organised with your gear and your fertiliser and so on. So once we've got everything happening, how do we manage those pastures once you've got a legume established? So to maintain a good long-term grass, okay, well, right. The final point of the slide is critical. So how do we manage our crops after we've got them going? Sorry about that, folks. We must reduce grass competition to our seedlings. and that can really overrun your pastures. It's really important to remove your cattle, obviously, for a few months while the legumes are establishing. Review your grass competition and do a light graze when grasses have high feed value, and then the cattle will tend to move towards the grasses and away from the legumes. And in leukemia, you might be thinking about putting on some selective herbicides. It's quite a good idea to encourage a seeding event in the first year, and this means that you won't be allowing grazing while the plants are growing and flowering and producing seeds, and you can bring those animals in. And in systems like the strip systems, you can go from applying at a few kilos per hectare to applying at hundreds of kilos of seed per hectare, which means you can quickly get a lot more legume into your pastures in that first year. From then on, you can spread it through grazing. And if you want to maintain a good grass legume balance, use good grazing land management practices. So make sure there's good monitoring of your pastures, pasture composition and yield, and that there's rest for both grasses and legumes. And remember that grasses tend to be eaten more in the wet season, so that provides us with an option for trying to manipulate the balance of grasses and legumes within our pastures. Okay, now some people love an organised table, and here's an excellent slide that Gavin put together for his previous talk. And the key message here is that there are a wide range of things that we need to consider when we're developing a new pasture. Each of these are quite simple, but you do have to be organised in order to get these done on time, particularly in our monsoonal environment where your planting window is so short. Okay, and I've kept Gavin's conclusion slide here because it rings true. Number one, plant legumes. We do have well-adapted, productive varieties available. We know that they are highly valuable within our production systems. And I agree completely, poor establishment is the most common reason for failure. It's also the most common reason for people not going back again. However, there are a range of steps that we can undertake to make sure that everything goes well. They're quite simple steps, and you can get reliable establishment if everything is done right. Now, unlike the Brigalow belt, where stored moisture is considered to be critical, in the monsoonal tropics, the trick is being organised and be ready to sow in a short planting window and be ready for that to move if the weather dictates it. Okay, so thanks everyone for listening in. Here's some more information through Future Beef and some information on the Queensland Pasture Resilience Program and broadly our DPI state extension teams. But if you are interested in finding out more and working with the team in the north, here are our contact details. There's a QR code to the QPRP project, and there's some people there who'd be very keen to have a chat and help you out if you're looking at developing your legume pastures. Thank you.